Zhaowei Liu Research Group covers a broad range of topics in photonics, mainly focusing on super-resolution imaging, plasmonics and metamaterials, and nonlinear optics. The group designs and fabricates metamaterials to greatly enhance the resolution of optical microscopes as well as to create devices for extreme optical nonlinearities and ultra-fast light generation. This station is a custom-built imaging setup for fluorescent super-resolution microscopy. The custom optics allows for higher speed laser scanning for the sample. Combined with specially designed metamaterials, this microscopy technique can improve image resolution by 5-fold compared to diffraction limit with high acquisition speed. This custom pump probe system is used for thermal conductivity measurement of micron scale structures, two-dimensional temperature distribution imaging, and real-time monitoring of temperature changes. This system is mainly used to study the interaction of light and phonons and evaluate the thermal properties of novel materials. The main light source used here is an ultra-fast femtosecond laser at near-infrared. It serves for many nonlinear and linear measurements, such as Z-scan experiment, second harmonic generation, and lifetime measuring. Here we have a high-power tunable CW dye laser with a custom-designed laser cavity inside. The laser allows for high-speed wavelength tuning with high output power for ultra-fast compressive sensing imaging. For more information, please visit ece.ucsd.edu.
Okay. We actually have currently one group member in the lab. Before that. Well, if you have more interest, then we can also ask our student to show you the lab at this moment. But I want to give you a very brief introduction as well. I think the video doesn't cover everything I want to see. So our group dealing with a lot of different kind of topic related with photonics, and we have a lot of computational work as well. So for that reason, we have a small cluster and put it in our supercomputer center, and dealing with all of the numerical simulation and also data processing and image processing, neural network reconstruction, all of that type of thing. So each of the group member can have a account, and you can just use your laptop to remote control, and you can do computational work. So then in this video, it mainly showed you one of our main lab for optical imaging and characterizations. That you can see a lot of microscope, lasers, and those kind of optical setups. And then we have the, I think the videos mainly is our second floor labs. And then we have maybe 4 or 5 optical microscope connected with various different lasers. Maybe we have, I don't know, maybe like 5, 6 different kind of lasers. And we covered from all the visible frequency. We have CW lasers and also pulse lasers. And that lab is mainly for imaging and then material characterization. So majority of the samples actually were fabricated in our clean room facilities. And so when we fabricate the sample, then we bring the sample back to the lab, and then we do the measurement in the lab. So far, is, within our group, we divided our group into the 2 subgroups. And the one is mainly related with optical, imaging, and then compressive sensing. So the spectrometry and those kind of topics. The other one is more like applied physics, including plasmonics, metamaterials, nanophotonics, all of those kind of related topics. So the and then the pulse lasers, and we have 2 types of pulse lasers, and they're mainly used to characterize the material properties, electronic information, electronics, phonon, plasma interaction, and then all of non-linear interaction, and then modulation and super continuum generation and sensing, all of those kind of related topics. So I guess I want to give just a very brief introduction and think. How about Junxiang? Can you open up your camera, and then I don't know whether we can do that right now.
Let me see. Actually, can you hear me?
Yes.
Okay. How do I switch to the?
Okay, we have roughly about 10 minutes. Yeah, I wanted you to show us the one thing is our this probe station. Yeah, right here. Yeah, this is the probe station, and then we actually can measure the optical properties. We put the samples inside the vacuum chamber. We can connect it to the electronics, and then we measure the optic from the windows outside, and then we can also apply the electrical signal, and there is electrical sources outside to deal with high speed is also fine. And then we have the high speed electronics up to 20 gigahertz. And then this is one with the vacuum chamber. The next one is just the probe station, and then the next one, the probe station. On the back side, the probe station.
Which one?
The probe station with the electronic rack right next to it. Yeah, you see the white box, the big white box in the back. Yeah, that's the one you have with all of this kind of electrical signal on. In the back. The probe station. The probe station.
Oh.
Okay. This is different one though. But
what are you talking about? Oh, you mean sorry, I got confused. You mean this probe station?
Yeah.
Okay.
This is one. It's a very regular probe station. This is nothing really fancy. I want to tell you mainly it's about this probe station and the next probe station. One is you can do this ambient condition, and one in vacuum. And then you can see in the background you have the white box, or that's all of the high-speed electronics. We basically try to apply the high-speed electronic signal combined with optical signal, and to deal with communication related topics. Okay, this is the electronics up to 25 gigahertz. Now we can go to the high super resolution imaging that setup. So all of this here, the whole table is for a different kind of version of super resolution microscopy, and then we build up the whole setup in the labs. But also we fabricate plasmonic metamaterial, this type of thing in clean room. We bring the samples back here. We put the samples under microscope, and then that sample will become part of the whole imaging system. Okay, with this help with the plasmonic metamaterial, we can improve the resolution of the whole system by maybe 3 to 10 times. And that basically give us the super resolution capability. Now, this system is mainly used for super resolution biomedical imaging. And then I think we are the first group to develop this high speed and super resolution imaging at the same time. We're talking about sub 50 nanometer resolution and video speed. Okay, and then there's this very special tool to study biomedical dynamics in live cells. Okay, and then around the corner we have the ultra fast high power lasers. There's this this is one of the lasers, the CW laser, a tunable CW laser, and then we built it up by ourselves and with some kind of modification from existing system. And then this is one meter system we use it for biomedical imaging. And this is the one is the high power ultra fast femtosecond laser, and we use it for nonlinear study and supercontinuum generation and the material characterization, all of this type of things. So all the nonlinear ultra fast type of thing can be characterized by this system. And we'll probably want to go to the back room. Then we have another nonlinear system which is similar to this one, and then combine it with the pump probe, those kind of experiment. But this is only for the low power. This is one with high power, and the back one is for low power. I think that's pretty much the major system we have. If you have any question, I'm gonna happy to answer. I also free to type your question in the chat windows if you like. Yeah, this is the back room, I guess. One more things, one more things that we have a few student office and one major student office. We have 13 cubicles in the third floor, and then this is one like a student office have 4 or 5 cubicles right next to this lab. So currently we we can incorporate up to like 19 students in the group at this moment. Yeah, this is another the multi system family second pulse leader. And as you can imagine, yeah, this is the system that we can use it to measure the lifetime of fluorescence. And then the resolution can vary from nanosecond down to roughly 20, 30 picosecond level. And we use this system to measure the light emission speed of the fluorescence and also the high-speed LEDs. And then, as you can see in the background, this system is about single photon measurement. We can also scan the wavelengths and so the lifetime calculations. And if you want to measure the nonlinear property, this is also capable to do so. I guess this is pretty much the major characterization facility in our group. And you can also tell there's a lot of spectrometers in the group. We have a multiple spectrometer and covered from the UV to near infrared. So we also have the mid infrared capability by collaboration with CMRR facilities, and then that will be able to extend the wavelengths up to roughly about 10 to 20 micron wavelength range. Okay, I do like to answer any question if you have.
Thank you, Professor, for showing us a lab tour. I have a quick question about you said you do a bunch of characterization of things that have built in the clean room. What fraction of the time do you think your graduate students spend in the clean room building and fabricating things, and what fraction of the time do you think they spend actually experimenting on them?
Oh, that's really depends on individuals. And then within our group, we have people 100% on the simulation. Some of the people, they spend most of the time in the clean room. Some of them spend most of the time in the lab. It really depends on individuals. And some of the topic, it could be very challenging to be, completely done by individuals, and it needed like a teamwork. And then, so I would say we also have the people in the group. They spend like a 30% on simulation, 30% in the clean room, 30% in the lab, like that. Okay, and how much percentage, as I said, it depends on individuals, and then we'll have a lot of discussion about that, and then try to make the maximize the overall efficiency within the group, and we encourage a lot of collaboration within the group.
Thank you.
Mm-hmm. Any other question? Well, if you happen to have more question, and I will be very happy to answer that during the one-to-one meeting. yeah, how your group will train the new PhD student. Commonly, we're gonna ask the new graduate student to work with the more senior student, and before the training, we need to spend quite a bit of time to identify the topic, which kind of topic you want to go, and then after that, we're gonna find a more senior student to work together with you, and then. In terms of the training, the meeting with me, we have the individual meeting with me every week, and of course, if our student need more meeting, I commonly just I encourage them to send me email to arrange a separate meeting. I would say the student training, there's no standard format, but most of the cases it's mainly done by the individuals, and they take initiative, arrange the meeting, and with more senior people and also me, and that can be done like that way.